y equals a times x minus h squared plus k. We will talk about what these parts of the formula mean. This is kind of similar. It's like the point-slope form of quadratics. So where point-slope was like you got a point, you got a slope, and it gives you everything you need right away. This is kind of like that. So the vertex is the HK. And we have to be careful. This is what tricks up a lot of students, as only the H switches signs. So do you remember when we did point slope formula, how the X and the Y switch signs? It was like X minus X1 and Y minus Y1, so you had to change the signs. Do you remember this? Okay, if you don't, that's your reminder. It's like that, except only the H switches signs, because the K is not in parentheses. It's outside, right? So X minus H is kind of like what you saw in point slope formula. We're going to do the same type of thing there. When we're getting the other points, we're doing it the same way. So you're going to create a table, plug in your X values, solve for your Y values. It'll be symmetrical around the vertex. Make sure you plot points from the vertex, both left and right. Remember, if you have like 2 points on the right, then you know right away what the 2 points on the left should be because it'll be symmetrical. All right, first one. We've got y is equal to x plus 1 squared minus 2. Now, the a value is what's in front of the parentheses. You don't see a number in front of the parentheses, so what do you guys suppose it is? 1. Okay, now here's the new part. The h switches signs. So Bella, what's h got to be? It's 1 in the parentheses, so switch the sign. It's going to be not positive 1, but negative 1. So this is my h would be here, but it changes signs. And then the k is what, Stevie? Negative 2 does not change signs. It's not in the parentheses. So this is your vertex, HK. So we'll answer a few questions before we get to graphing this. The a value still tells us which way it opens. So we know that the a value is positive 1. So guys, does it open up or down? Up. It's a happy parabola because the a value is positive. And then since it opens up, will it have a max or min? You could say it out loud. We already know the vertex. That's what's so nice about this. You don't even have to solve for it. It's in the equation. Our vertex is negative 1, negative 2. You don't have to solve for the axis of symmetry either. Can you please talk to the person next to you and tell them what would the axis of symmetry be and how do you know? Bingo. Goes right through that vertex. Domain, what do you think it's going to be, guys? Yep. And we can do the range without even graphing it as well. It goes from, so the vertex is a minimum. So it started at negative 2. Less than or equal to y. Less than or equal to, no, not less than or equal to. Less than infinity. My bad. So that looks really bad. I'm going to change that. Less than or equal to y, less than infinity. The y-intercept, we are going to have to solve for. So we've done everything we can. We're going to make a table now. X, Y. Okay, we're going to make our table now. The vertex goes in the middle. Negative 1, negative 2. So do the values surrounding that. That's what probably makes sense. I'm going to do 0 and 1. We need the y-intercept. So that's why I'm going to for sure make sure I do x equals 0. And negative 2, negative 3. I personally don't really like dealing with negatives in quadratics because I sometimes mess it up. And so I'm going to choose to substitute 0 and 1. You can do that now. If you're confused on how to do this, watch up at the board and I'll do it with you. So I'm going to plug in 0. So y is equal to, in parentheses, 0 plus 1 squared minus 2. So 0 plus 1 is 1. So 1 squared minus 2, which is 1 minus 2, which is negative 1. So when x equals 0, y is negative 1. Let's just do one more, and then we'll make our table symmetrical and graph it. So do the same thing for y, or x equals 1, y equals, in parentheses, 1 plus 1 squared minus 2. So that would be 2 squared, which is 4. Minus 2 is 2. If you're looking at this like I did earlier and was like, that doesn't look right, remember our vertex is a minimum and it's going up. So the values are getting larger. Negative 2, negative 1, 2. It looks okay. Now we have to make it symmetrical. So negative 2 would also be at negative 1, and negative 3 would also be at 2. Do we know our y-intercept now? Yeah, it's 0, negative 1. This guy. If for some reason it was not in your table, then you could graph it and see what point it is, but I would prefer an exact value. So go ahead and graph those points now. Make the parabola. Remember, parabolas should be rounded. They're not straight lines, they're curved. So negative 1, negative 2. 0, negative 1. Make sure it's got arrows showing that it keeps going to infinity and beyond. If you want, you could draw on your axis of symmetry going through negative 1, but you don't have to.